here is plasma. The cosmos are primarily plasma. The Earth, or planet, is an anomaly. To have something of this form, this is an anomaly in the grand scheme of things. So most of this universe, as we would know it, is of plasma. So plasma now becomes like, it's a bit important, right? It's not the little guy here. And the simplest example I can give you of what does this mean in real life effects would be a neon light tube. Most of us are familiar with the neon light tube. And what is happening there? You have this tube, and it's filled with gas, right? There's no wire. There's no wire. It's this tube, and what happens? You subject it to energy, and it lights up. That gas is conducting that energy without a physical medium other than the plasma or electrically charged gas itself. I have this Van de Graaff generator. This thing generates high voltage. It's one of those fun things you play around with. But you put your hand on it, it's generating high voltage, and you hold this neon light tube, right, and it's lighting up on you. No wires. Okay. So the grand picture that comes out of this is the real consideration, not just an idea, but the real consideration that the atmosphere can, and apparently is in the process, and now has been altered to the point where it has become an electrically conductive medium. More so, by far, than nature. The ionosphere, many of us have heard of the ionosphere, which is a charged layer. It's how ham radio got started, and all the first radio, bouncing off top. It's this layer like 60 to 100 miles above us, that it is an electrically charged layer. And that is responsible for the propagation. The first time we discovered that you could send energy all the way across the continents was like bouncing off this ionosphere, right? Well, the fascinating thing to me was, there's a statement there somewhere to this effect, but gosh, I only made it through number one. This ionosphere, 3% of the mass of this ionosphere is electrically charged. In other words, just a little bitty portion of it is electrically charged. But it totally changes the physical properties of that medium. The point here is it doesn't take much to cause an entire change once you have the ability to start having electrons in there. See, the air by itself is this excellent insulator. If it was pure, it has almost no electrons in it. It doesn't conduct electricity at all. But if you can just, it's called electron density, but if you can increase that electron density at all through any means, you get to change everything in terms of the way the game is played of sending energy from point A to point B. That's what this is all about. And what's happening here is I'm talking about 1, 2, and 3 a little bit all at the same time. Okay? There are applications here between all of these things. Now when you're dealing with the ability to send energy, it changes things. And weapon systems have to come into consideration. They just do. Okay, I'm going to hold off on this because I'm going to go to that last section, which we're getting to eventually. We're going to be focusing on this. And these these are not discussed in detail as much in my work over the years. This one does have some. There's quite a bit there on magnetics. The question that's coming up there, is it actually possible where the planet as a whole could actually be affected, the geophysics of the planet be affected? And it sounds a little bit far out when you first get involved in it, involving rotational rates and magnetic fields of the Earth and this type of thing. All I can say is there's a body of work there that says that, yeah, it actually seems possible that we could actually be dealing with things at a planetary level that could be causing change by the environment. And it has to do with the ability to store information. I'll give you this picture because it helps me. And, you know, the HARP thing ties in. And I shouldn't say HARP without saying what it is, so holler at me. But, you know, HARP is an ionospheric, quote, ionospheric research station through the Air Force. It's a facility which is specifically dedicated, at least in theory, towards the study, right, and scientific research of propagation of energy in an electrically charged medium. That's what it's about. Okay, to give you a sense, like this planetary thing is not, this is not far-fetched, what I'm leading to. if you read this patent by a guy named Bernard Eastlund, he was the author. You see, on the patent, it won't say the word HAARP. This patent by Eastlund, I would consider as the blueprint. It appears to be the blueprint for the development of HAARP. But Bernard Eastlund develops this patent that describes the methods of the HAARP technology. And over time, I've made the effort to read that thing in detail. It started out being a lot of, all the stuff that people don't like to read. But I took the time to do it over the years. And the more I read that thing, the more fascinating it became. Because that patent, in many ways, captured the very essence of these things that I'm talking about to you. Four out of it, even 5. Even this one, 5 of these things. Maybe even 6. Are actually embodied within that patent if you start to read this thing. Well, here's one that really sort of caught my attention. And there's many of them. This is one example. And the point here was, is it possible that we could be dealing with planetary effects? Okay, he mentioned this thing called a heave weapon. H-E-A-V-E. Okay? And I say, what the heck is a heave weapon? And what it is, a heave weapon is when you use a magnetic field of the Earth and you build up energy. Okay, there's something called ELF, extremely low frequency waves. We have this radio spectrum and lots of parts to it. ELF means really, really, really long waves. Okay, and they have all kinds of implications with respect to even our bodies, because our brains work. We function in those ELF ranges. Okay, so the patent, the Eastlund patent, will talk about these ELF waves and such. And so he starts talking about this heave weapon, and to learn what it is, well, you build up energy, and in my mind, I can see it. I mean, I've never seen it described or beyond this or pictured, but in my mind, I can see it because I've gone through the math of this energy buildup. But if you take these low frequency waves and you work on resonance, and you keep building and building and building this energy, you're talking about something that's grand scale, okay, literally the size of the Earth. If you do this enough, the heave weapon is described as a weapon that lifts up the magnetic field of the Earth and shoves it back down. It's like this. The magnetic field of the Earth, okay, to lift it and slam it down. And how is it described? It's described as a weapon that has all the power, literally, I mean like numerically, all the power of an atomic weapon, but no bomb. Okay? This is the level of which things are described at. Okay? And on my side, I did work to figure out this energy. Is it actually possible to do this? And you'll see the work, but this is where this came from. That yes, it looks like it's actually possible. Now, obviously, Eastlund, he had something figured out, but I had to go on the backside and try to say, well, with what I'm dealing here, does it make sense and all that? And my conclusion was, yeah, I got to be considering these things. Okay, we're going to punch, I think, through the rest of these. This is a global warming model. Okay. And now we're going to start working into that second section. How are we doing on how much have we used versus
3:35.
how much time have we gone, do you think? Roughly. If you don't care, it's okay with me. I don't care, but
An
hour and 15 minutes or something? What's that?
About an hour and 15.
Hour and 15. And I was supposed to go an hour and a half total, and I haven't even gotten to the second section yet. Okay, so there's this. We're going to start bridging now, and I'm thinking we'll take. It depends if you can last long enough. Take a break after I'm done for then questions. But if you want to take a break, if you need or want that, I could do it also because this next section is like the other half of what I was going to cover today. What do you guys want to do? You want to keep going?
Yeah.
Okay. Okay. All right. So let's go. And this is like another. I've never done this section before at the depth that I hope to get through it. And it's probably equal in substance easily to what we've done. Okay, now we're, that topic I had there, this one, biological. Well, not to diminish these. Again, these are all on equal standing. But this one over the years took on special interest, I guess, is how I would say it. because it starts really early. If we dig up the